Hi. Well, first of all, thank you so much for inviting me for giving a speech to Learning from Imperfect Data workshop. And I'm very honored to be here and present what we're doing and what type of things we will do in the future. In my opinion, this is one of the most important workshops at CVPR since imperfect data is one of the things that everybody is dealing, and then everybody has a pain of creating a better and better data set because, as many of us know, algorithms are staying the same often, but the data is the thing that improves the model as we go towards the production models. In this talk, I will talk about tools to share data sets and find imperfect data specifically for computer vision applications. I'm Vahan Petrosyan, co-founder and CTO of SuperAnnotate. So let's get started. At the beginning, I will give you some background and then jump into tools for sharing a dataset with community and then talk about the values of that. Once we're done with that, we will talk about different types of tools of finding the imperfect data, and at the end, we will conclude the presentation today. So let's start with the background. Actually, there is a very interesting story related with SuperAnnotate and CVPR, since in 2018, when the company was not really created, I was a PhD student at KTH, Royal Institute of Technology in Sweden, where I have a very accurate and fast superpixel algorithm that I didn't really have any applications that could be applied in real world. But once I attended CVPR, I saw many different annotation service companies that were trying to buy the algorithm from me, and that gave me a really good idea that what we created with my professor, has a wide range of applications of really quickly annotating data and then creating a really high quality training data set 10 times faster than what was originally at the time. And it was actually during the CVPR that I connected with my brother in Switzerland, who was a PhD student there, and asked him, should we actually create a company? And it took me like 1 to 2 months to convince him. And eventually we ended up dropping out from a PhD and created the company just because we attended CVPR and saw all these different applications that can be applied. So really honored to be here at CVPR 3 years later and show what we have built and what we will build in the future. As I said, we created the company in 2018 with me and my brother. We so far raised $18 million from one of the best Silicon Valley and European investors. And at the moment, we have around 60 CV enthusiasts located in US, Sweden, and Armenia, and are growing our team to create better and better tools for CV engineers, for annotation groups, and so on. And I couldn't really not mention how proud we are with our advisors that are helping us to create better tools, seeing the better future in computer vision field. Namely, Professor Trevor Darrell, who is giving a speech in this workshop, is the co-founder and co-director of Berkeley Deep Drive. Professor Peter Abil, who is the co-founder of Covariant AI and also the director of Berkeley Robot Learning Lab. Also, one of the organizers of this workshop is an advisor, Professor Mingming Cheng, also professor in Nankai University. And last but not least, Gary Bretsky, who is the founder of OpenCV. We are very proud of working with these people to even accelerate future of computer vision. So what we're building as a company is a software that is helping people to accelerate the application development in computer vision products. So this might sound a lot of cheesy words, but let me break down what it means to create a successful CV product. First, what we built is an annotation platform where we help annotators, QAs, admins to collaborate together and create really high quality training data where you can do project management, quality management, file management, and all that infrastructure around the annotation. The second, what we built is we went and talked with over 300 different annotation service companies and got a lot of industry insights where those annotation services are located, which companies are providing a really good quality. So now when we have customers that are coming and asking us for annotation services, we created this marketplace where we direct our customers with which company is going to be the best fit, in which location, in which price, and so on. So we allow them to pick several annotation companies to work with, and then we are the ones that are managing those companies. The third thing, what really helps you to close the feedback loop between the annotation and model training, is we created a one-click model training platform where you can easily create your custom models, automate the annotation process with your newly created models, and at the same time download your own model and apply it into the production. And then last, again, but not least, is we have created a data curation system, which really allows you to query, find, and correct all the imperfect data that you have annotated in the past. By this, we're closing the feedback loop between the annotators, CV engineers, project managers, and helping them to collaborate faster and in more efficient way, while at the same time creating the highest quality training data. So enough about the company. Let's start the talk about talking about sharing public dataset. So what does it mean? Why do we need to share public dataset for computer vision? So you may think that Kaggle is already have a place where people can go and search datasets and eventually download those datasets as part of their research project. But computer vision has very different specifications where you don't only need to kind of share a dataset where people can go and download it, but the very important component in computer vision is that you need to create a platform where people can search the part of the dataset that they want, visualize that dataset with the annotations on top of each other, and download maybe the part of the dataset. You can imagine that some datasets are hundreds of gigabytes, and you cannot simply go ahead and then download the entire dataset, because you might be interested only the part of the dataset that you need to perform your experiments. And therefore, what we created is this platform where you can not only search dataset, but you can enter and visualize what's inside the dataset. So here what you will see is that I can search all the images, for example, that has more than 10 different bounding boxes, and I can search all the images that have a class that contains a ball. In this way, I will create a subset which contains 82 images, and then I can visualize those subsets because I'm not really interested in, for example, images that have a referee in it. Once I find and query my dataset, I can easily download part of that dataset, and if in case I need to visualize it differently, then maybe instead of 3 columns, I can put 1 column to see a smaller objects, or if I want to see a larger picture, larger view, then I can increase the number of columns and then see more images and visualize it faster and explore my dataset faster. One of the other applications of sharing datasets could be that you can upload the predictions of your novel algorithm to the platform and then share it with the community. So this will really help you to visualize your prediction and share, as people might be interested how the algorithm is performing on a subset of your predictions, where you can go query and find the things that you're interested in. And you can also compare your predictions with other predictions and then show it into the same picture, as it might help people to understand what are the differences of two different algorithms and how a certain algorithm is performing better than the other one. As a result, you can easily make your predictions available to everyone, and rather than uploading a few examples where we generally cherry-picked the best performing predictions, we can give an ability to the entire community to read the papers and then see how the novel algorithm is performing on the entire dataset. Okay, let's jump into the imperfect data and what are some challenges that we're facing with the imperfect data. For this talk, I wrote down 4 different challenges, and one of the most important challenges is the bias in imperfect data. Once you find the bias, then we need some type of tooling to find that imperfect data easier and then make some corrections to that imperfect data. Very often what's happening though is that once you're making your corrections, you realize that the new data set is performing worse than the previous one. So it is very, very important to version your data and have an ability to come back at any point in time where you can recover your previous annotations and continue from that point. Last one is being able to handle the corner cases efficiently and balance the classes that you have, since the class balance is in general one of the main problems naturally for computer vision datasets. So let's start with an example of a bias. Let's assume that you have 3 different classes and correlation between the bike and the car is 0.35 for Rick, who is our annotator, meaning that whenever Rick is annotating bikes, there is a high chance that there is also cars in the image. But the same thing is not really relevant for Jen, who did the same annotations, but then they found only 2% of correlation between bikes and cars. In this case, means that there is a really high bias in your dataset, and then somehow we need to address those class correlation bias to be able to move forward. But other than class correlation bias, there can be all sorts of other biases, which in this case I wrote down a few on the left side in here. So annotator bias was one that we just discussed, but it can be simply the QA bias. The quality assurance person might approve and disapprove images in a way that it contains a bias there. Or there can be simply a time bias, because very often when the annotators are working on some images, as they start doing more and more this mechanical work, then they tend to create a bias in their datasets as the time goes on. So it's very, very important to have tools to check the time bias, and then if there is a time bias, have tools to quickly correct them. So some other sorts of biases can be the class bias, attribute bias, image size bias, because larger images might have certain annotations than smaller images, and so on. So what would be important when you're creating your training dataset is have an ability to record all these different things and be able to query and search based on this, and then create some dashboards that will allow CV engineers to find those biases really easily. So here on the right side, we're showing you an example JSON file of our output file, where we're recording not only the box coordinates and the class of the box, but it can be the attribute of the box, when it was created, who created that, under which role it was created, and so on. Given that each bounding box is coming with all this information, that will really allow you to find and create tools to check those biases and correct them as you do more and more annotations in the future. So let's say you have a bias and now you need to find those biases in your imperfect data. So some of the steps to find those biases would be at the beginning, query and visualize your data set and find the biases. And once you're visualizing the annotations and predictions and the images on top of each other, then you can perform some actions, which is really going to help to identify the bias at the beginning and then correct the bias by doing bulk operations. Let's say you say that all these images should be redone, and then you can just select the entire images and then change the status and send it back to the annotation again. And since we're keeping all that JSON information, it will be really easy to filter the subset and then perform that actions on that particular subset as you're dealing with really large data set. So here you can see that it's an example of an imperfect data. There is a 3x3 images, and then in the middle you can see that the image has a really large polygon, which can be really easily identified once you do the right search. So in this case, the right search would be, give me all the instances that have a polygon, and if my data set consists of bounding boxes, then I shouldn't really see anything that has a polygon. So one of the other things that we talked about is the versioning the imperfect data, because as I did my changes, maybe my algorithm will not really perform the way I'm expecting. So on the right side in this image, you can notice that our platform is allowing you to create different versions and then create the timestamps of your versions. Since, let's say I'm going to make changes starting from tomorrow, let me kind of fork that annotations and then make the changes there. And in the future, once everything is great, then I will push it back, similar to GitHub, and save the new versions of the annotations, while the old versions will still be there, and I can recover it at any moment that I want. And then last is dealing with the corner cases and dealing with class balance, which in our platform, we're solving it in the following way. So on the right side in the image, you can see that there is an entropy column that is associated with each image. And the entropy is some sort of measure of uncertainty. You can think that if you have a high entropy, then that image should be annotated first. And what we are very proud of is that our machine learning research team created a metric that is really encouraging a class balance, and then finding automatically the images that will have images from a certain class that is not really present in the future. So you can create. So here I'm, I think, visualizing how that process will look like. On the left side, you can see that we have this model creation, one-click model training and versioning place where, let's say, my third object detection version is performing the best, and I can apply that object detection algorithm to automatically identify the entropy scores. And then once the entropy scores are identified, then the annotator can request the images automatically with the highest entropy score, which is shown on the right side. And that way you will create a model, you will give the importance to your images, and the annotators will only annotate the most important images, which will really force to create balanced data set, as you might have this pain. So some of the conclusions and future work what we're doing is that public datasets can be visualized, filtered, and downloaded easily and a lot faster. And you can also publish some papers where you can upload your predictions and allow the community to visualize your predictions versus somebody else's predictions and compare them easily. We also know that finding mistakes in data sets and in imperfect data set is very hard. So we created this query system where you can make it easy and find those mistakes and then also download them and also correct them. And more or less the last conclusions that we have is tools for finding and quickly fixing such data sets are as important as creating robust algorithms that will be not sensitive to those errors, because having a perfect data set and somehow slightly worse algorithm will give you even a better advantage rather than creating a really robust algorithms. So this was it. Thank you very much. I'm again very honored to give a speech for this workshop. Let me know if you have any questions. Yep.